Good evening, friends. Welcome to the domain analytics session. So we were looking at energy and resources analytics. In this, we had seen our various applications. Yeah, we had seen various applications. Then we went through the project management methodology, CRISP DM, or the new one, CRISP MLQ. Then we saw how to means collect data and correct the data according to the ML algorithm. So that was EDA and pre-processing. And then we were in the step data mining. Then the step data mining step. We saw majorly it is divided into two parts. One is unsupervised. Second one is supervised. So under unsupervised, our output is unknown. First of all, why is unknown? Also, we don't have a training phase or supervision phase is not there. No training. Okay, and under this we saw K means clustering. K means clustering, which clusters similar records together, which is found by using some kind of distance formula. Okay, it uses distance formula to calculate similarity, and based on this distance we can make clusters. So this was unsupervised. Now we'll have to we are going to supervise. Okay, now the supervised model. Okay, the supervised models. Let me talk about this first. Okay, so here in supervised models, we start up with a data set, which by using simple random sampling. So this is the data set. By using simple random sampling, we will split the data set into two sets. One is train, another is validation. Using the train data set, we will use some ML algorithm and find out a mathematical equation which relates this x and y. X is all the inputs. So inputs may be one or many, all the inputs. Then output, which is one row, one column only. Okay, this here we find the mathematical equation which relates x and y. So one of the mathematical equations we can show using y equals to mx plus c, or this could be also written as in terms of regression if you're talking about beta 1x plus beta 0. Okay, where beta 1, beta 0 are some constants. Beta 1 is known as coefficient of x, It is also the slope of the straight line. Also beta 0 is y-intercept. Okay, so using this math equation, okay, math equation basically we here find out the beta values, beta 0, beta 1. These values we find, and this is our math equation. Now on the validation set, we will use this math equation and this validation set to make predictions. And here we will get the predicted outcome. Okay, this predicted outcome, then we can also evaluate because we are also having the y value here and we are finding the y hat value. So the evaluation can be done by comparing y and y hat. If we are talking about, so we'll be talking about this evaluation, how to do it, we'll be talking about. So now supervised model, okay, they are again divided into two types. One is classification, another one is regression. Classification is when the known y is category, it has classes. And regression is when y is a continuous value. Okay, here y is categorical, here y is a continuous value. Okay, but with regression, this finding this math equation is very easy. So regression, there is no issue. But in classification, okay, we are having categorical data. So this relation cannot be done simply like using some math formula. So here we have some other techniques. These techniques are known as shallow learning techniques. Shallow learning techniques. These techniques, so basically three major techniques we are having in this. One is probability method, using probability, which is shown by naive Bayes model, Bayesian model. We are also having distance-based model, distance-based classification model, which is shown by KNN, which is our topic for today. Then we are also having some rules-based. Okay, rules-based. We are having decision tree. Okay. And in regression, similarly, we are having. So these are continuous. So math equation can be directly formed. So here no need to have any shallow learning model. We can directly do this. So here we use simple learning. Simple linear regression, multiple linear regression. Okay. Then we are having logistic regression, which is actually a regression problem, but we model it to give us categorical value. Okay, logistic regression, and many more are there. Means we are having this multinomial logistic regression, ordinal regression. Okay, many other regression are there we can use. Okay, but majorly these three are present. There are multiple variants of different models of these three. Okay, so we are now dealing with classification model. So classification model evaluation differs for classification and regression. For classification, we cannot, find the difference between them. We cannot do any mathematical calculation because these are categorical values. So for classification, what we will do, we will form a confusion matrix. Confusion matrix is a table, 2 into 2 table, where we can compare the value of these two. So here we compare y equal to y hat or not. Okay, we compare this, and based on this, we find the accuracy. We can also find error. We can also find something known as recall, specificity. Recall is also known as sensitivity, specificity, and many more things. Okay. Many more things we can find. Okay. So these are all evaluation metric for classification. So when doing classification, we can use any of this evaluation metric. Okay. When is the sensitive data like a medical data, we will generally use F1 ratio. Okay. Otherwise, we can use accuracy. Now, similarly for regression, also we are having many evaluation metrics, but generally we use error calculation. Okay. In error also we stick to RMSE or MAPE. RMSE is root mean square error. MAPE is mean absolute percentage error. Okay, these two we can use. Also, there is another term, R square, which we often use. Okay. So this will be seen when we'll be seeing the regression model. What is R square? What is RMSE? What is MAPE? Okay, this will be seen. So let's go on to KNN. Okay, let me tell you something about this confusion metric first. It is a 2 into 2 matrix where we tabulate actual value with predicted value. Okay, so we are having this kind of matrix. Okay, we are having true positives, true negatives. So the value which are actually true and also prediction also it is coming true. These are true positive, and which values are actually negative and also in prediction they are coming out to be negative are true negative. Similarly, false positive are which are predicted false but are actually positive, and false negative which are predicted negative but actually positive. So we are having this. Okay, from this if you want to find the accuracy will be, suppose this is A, B, C, D. Accuracy will be A plus B, all the true values by total values, and error is B plus C by all the false values. Okay, I think this is false positive. This is false. Okay, so this is false negative when we are having actually it is true. Okay, actually it might be true, but in prediction it is coming false. So this is all about confusion matrix. There are multiple other things also we can measure. So let's see this classification technique KNN, which is a distance based classification technique. Distance based classification technique. So let's see this. Okay, so we'll be learning the nearest neighbor classifier. How does it work? Selecting the k value. What is one nearest neighbor? What is k nearest neighbor? How to control the complexity in KNN? Okay, what is Euclidean distance? What are different advantages and disadvantages of KNN? And some use cases. Okay. So in nearest neighbor classifier, Okay. Suppose we are having this and we are getting an image like this. Okay. So KNN classifier, also known as lazy learner. Okay, it doesn't have a training phase. Training phase is not there, but it does training when it starts testing. When it gets a test sample, it will start training them. Okay, it will compare this test sample. Okay, using the distance formula, it will compare with all the samples. It will start comparing with all the samples, and wherever it finds the closest, okay, whichever sample it is getting the closest value, okay, it will be categorized in that category. Okay, so this is how we can say it is an overview of this model work. Okay, so how does it work? Let us see. It looks at the data first. Okay, suppose we want to classify this point, this data point we want to classify. Okay, so what it does, okay, it first measures the distance from all the data points. Okay, so whichever distance will be the closest. Okay, depending on the number of k you have chosen, whichever distance is the closest, we'll take that. So let me tell you. Okay, so k value, suppose we have taken 3. So it measures the 3 closest values. Suppose this yellow 2 and green, it measures these 3 are the closest to this, suppose. So when it measures, if we are having a majority class or majority category, so we can see here yellow is a major category here. So it will fall in this category now. Okay, it will also become yellow. Okay, it will also become yellow if k is equals to 3. Okay, so similarly, depending on the different values of k, it will fall on different. Suppose k is equal to 2, it will take this, it will also take this. If this is the case, okay, it is taking 2 and there is a conflict, so then we'll also take distance into consideration. Whose distance is smallest, that will be the class. Okay, so we start by calculating distance between all the points to the gray point. Okay, then if we are considering first nearest neighbor or one nearest neighbor, we see that this is the one, so it will be yellow. If you are considering 2 nearest neighbor, so still it is 1. If you are considering 3, so still it will be this only. 4, then this is the 4th one, which is closest. Okay, but here who wins? The class yellow wins the vote, because you can see we are having 2 votes for yellow. Okay, so basically think of this is what our distance is looking at, this data points in the circle. So here we can see 2 yellows are there, so it will be classified as a yellow point. Okay, so it is the votes are votes on the predicted class labels are based on classes of the nearest neighbors. Okay, so majority vote decides the class. Okay, so let's see again in text it is written. So KNN working can be explained on the basis of the algorithm written here. So first we select the number of k. Okay, it is very crucial selecting the k value. First we'll select the number of k, the number of neighbors we are having. once we have got this, okay, once we have got the number of neighbors, next we will calculate Euclidean distance of the k data points from the you can say data point. Okay, nearest data points will measure the distances, and we'll take all those who are the shortest, and first k numbers we will take. Okay, shortest k values or shortest distance values, k neighbors will take. Okay, take the k nearest neighbor as per the calculated Euclidean distance. Among this k neighbors, count the number of data points in each category. Okay, we'll count the number of data points present in each category. Whichever category has the more number of points. Okay, assign the new data point to the category for which number of neighbors is maximum. Okay, so this is how we categorize the data point. Okay, new data point. Now, some things you also need to remember when you are selecting the k value. When you are choosing the k value, you should remember this. If k you are choosing the line, k you are choosing 1, the classes are divided into regions, and the query record belongs to a class according to the region it lies on. Okay. And if you are having a 2-class problem, a binary category. Okay. If you are having a binary category, so for this, the k value to be chosen will be odd values. Odd values of k should be chosen. Okay. Also, if we are having k classes, okay, it should not be this k value should not be the multiple of number of categories we are having. Okay, it should not be, if suppose we are having 3, we cannot take 6 as our k value. Okay, so number of categories should not be a multiple of k. Okay. So if we are having this n, I suppose, so n, where n is the number of classes, we cannot take this. Instead, we'll take I plus 1. Okay, this is what we'll take. Okay, so now let us see with an example. So here you can see this is a new data point which we need to classify. This is a new data point which we need to classify. So we are first taking one nearest neighbor. When we took one nearest neighbor, we calculated all the distances and we found the shortest distance. So this is the shortest distance point. So it is pink in color. Okay, so the category will also become pink. Okay, this will become pink. Now we saw 2 category. When we took 2 category again, you can say pink also, blue also. So there are no majority categories. So what we will do? We will again find the distance between them. So first distance between this and this is so shorter. So again pink. Now 3. Okay. When we saw 3, we saw that blue color is coming up as the majority. Okay, so 3 cluster, when we did, it became blue. Instead of pink, it became blue. Okay, so majority category wins. So as we are having 2 blue colors, 1 pink color, our data point become blue. Similarly, we keep on increasing, and at last we are taking 8 nearest neighbor. So here we are seeing 3 blues and 5 pinks. So it became pink again. Okay, so similarly, you will have to choose the number of k values very carefully, because according to this only your category will be chosen, your class will be chosen. Okay, now selecting when the discussion is selecting the k value. So we should control the complexity. We should not choose a very high value of k or very low value of k. Okay, so we should be able to control the complexity of k and n. Okay, so you can consider this. Okay, let me just clear it. Okay, so here we are having different values of k. Okay, for different values of k, we are having this. So what happens if we are taking a very high value of k? We are taking a very high value of k. We see that training accuracy keeps on increasing, but validation accuracy dips. So this is something which we had already seen in pre-processing. This is a thing which is known as an overfitting problem. Overfitting. Okay. So the k value could be at max chosen up to this, because after this, the validation test accuracy starts dropping while the training test accuracy keeps on increasing. So basically, if you are having a training accuracy of suppose 1 and testing accuracy or validation accuracy of suppose 0.6, it is overfit model. Okay, it is not a right fit model, it is overfit model. Okay. Now here, so we should choose this k value very carefully. If you are taking a very high k value, it might overfit. Okay, now let us take a sample data here. Okay, so we are green peel cucumber nuts. Just so this data we are plotting like this. So in this data, if you look carefully, you can find some similar. Okay, so you can find these are similar. Okay, let me change the color. You can find that these things are similar. Okay, and also these things are similar, and also these things are similar. Okay, so we can say these are all green vegetables or vegetables, we should say. These are all fruits and these are all protein products. Okay, so let us see. So you can say these have been also categorized accordingly: vegetables, proteins, and fruits. Okay, so this is our data. Suppose this is our sample data we are having. Now, Suppose a new data point comes up. Okay, tomato. It comes up. So here we need to now find which category this tomato belongs to. So we start measuring. So the closest neighbors we see. Suppose we are taking one neighbor. Suppose if we take one neighbor, suppose it is coming under nuts. Okay, so nuts means protein. So with one neighbor, it might be we are getting protein. But then we increase the neighbor. We take two neighbors. Two neighbors when we take, we see it is also, we are having green bean, but as distance of nuts is smaller, it is still a protein. We are capturing it as a protein. Then we take three. Three also, it is still a protein because this grape suppose comes into the picture, which is a fruit, but the smallest distance is still for nuts only, so it is still a protein. But then when we take four, when we take, suppose this is orange, now it comes out to be fruit because majority is fruit. Okay, like this, the k values, according to the k values, the this will change. The category will change. So let's see. So how to do that? Measuring similarity with distances. So here we are trying to locate the tomatoes nearest neighbors, okay, by a distance function, okay, like Euclidean distance, or a formula that measures the similarity between two instances. So there are many different ways to calculate similarity or using distances. So traditionally we use Euclidean distance, okay. So Euclidean distance, we can say it is also the distance which one would measure if it were possible to use a ruler to connect two data points. Okay. So this distance we showed here, this dotted line. Okay, this is the Euclidean distance. Okay, it is given by the formula this. If we are having two data points, suppose we are having P point and Q point, and this P point has some values for each variable, suppose 1 to n. Okay, so P1, Q1, P2, Q2, like this up to Pn, Qn we are having. Okay, so the distance formula between P and Q is given by this. Okay, where P and Q are examples to be compared. Okay, we'll have to compare the distance between them, and each having n features. So there are n features total. The term P1 refers to the value of the first feature of example P. Okay, first feature is P1, while Q1 is the first feature for Q. Okay, like this, we are getting this, and using this, we can find the distance between the two. Okay, now we are given the value for sweetness and crunchiness. Based on this value, we will find. So basically, what we are trying to do, let me show you here. Okay, so you can say here, we are trying to okay, so let me just write it down. So here we are having Andes tomato. 6 and 4 value we are having. So we'll calculate this tomato. So to calculate this, we can do like this: root over of 10 minus 6 whole square plus 9 minus 4 whole square. Okay, this distance I'll measure again for this, again for this, again for this. Everywhere we'll measure, and whichever suppose, then we'll take the k value. Suppose k is equals to 1, so whichever is closer, we'll take that category. K equals to 2, whichever is closer, that category. K equals to 3, whichever is having higher majority, that category, like this. Okay. Now let us discuss the advantages and disadvantages of using KNN. Some of the advantages of using KNN are: there is no training phase, okay, and it can also learn complex models easily. It can work on complex model, and it is also robust to noisy data. Even if you feed it noisy data, it will not be affected that much. Okay, so these are all the advantages of using a KNN algorithm. But there are a few disadvantages also, like you will have to decide the number of k value. If this is not chosen correctly, your categorization will not be done correctly. Okay, so different k value will give you different results. So you must choose this k value very carefully. Okay, now also it is hard to apply on very high dimensional data. If we are having a very large data, it will be very hard to apply. Also, computational cost is very large or very high, okay, because we'll have to find the distance between all the data points with one. If we are having a very large, very large dimension data, it will be very hard to calculate all these distances in a short time. Okay, it will take a very long time to calculate. Okay, let's talk about some of the use case of this. So the use case on which I have worked on, okay, it is customer churn prediction for utility industry. In the utility industry, we are trying to predict if the customer will churn or not, given the features. Okay, given all the variables, whether they will churn or not. So this data is taken from PowerCo, and this PowerCo is experiencing customer churn, as they assume that the churn, this PowerCo, they assume that churn is due to some customers price sensitive. They are not means happy with the price. So this is what PowerCo believes. So we are trying to find out actually which are the reasons. Okay. So for this, they have also devised a solution that they will offer the customers who are having a high possibility to churn a 20% discount also. So what is this churning? Let us discuss. Okay, so customer churn or churn is when a customer leaves it. The customer leaves the company. Okay, it leaves the company for any other company. So generally the market leaders, they don't want this to happen. Okay, if they somehow want to retain their customers. Okay, so for this they might devise many plans to keep them afloat. Okay, so what we are doing here, we are having a customer churn history. So this is a previous data set we are having on how or under which scenario or under which conditions the customers are churning. Okay, then we are also having this existing customer base data set. We are having this data set also, we are having this data set also, we are having. So we'll be using some machine learning model, okay, to predict who are the high risk customer who might churn. Okay, if we detect this high risk customer, we'll transfer them to customer retention department, and they will try and make offers for these people. Okay, Now, if there are happy customers, no action is needed. Okay, no further action is needed. Okay, so here we are talking about the this energy market. So it is a very competitive market, competitive energy markets for residential customers. Okay, and they have been establishing customer retention through pricing driven contracts as well as quality of service. Okay, so these are the two things which are thought to be major things which we can retain a customer through. Okay, now we want to find the leading indicators of a likelihood to terminate a relationship or the customers to churn within a specific time range. Okay, with a provider that would empower the firm to make future decisions. Okay, to empower the firm to move proactively to engage the customer in an attempt to retain them or to in an attempt to continue to provide energy to them. Okay, so in this also we had done some EDA where we saw according to the given year what was the retention rate, what was the churning rate. Okay, so we can see from 2009 our data is existing. So 2003 the usage means the number of companies were very large. Okay, prior to that very small number of companies were there. Okay, so in this 2016 also this 2016 you can see this blue one is the retention, orange one is churn. So every year some people are churning, or every month we can say. Okay, so this is start date when they started, and this is the end date when they churn, or our data sets end date, you can say. Okay, similarly we are having here modified or when they renew. Okay, we are having this data set also. We did this as a part of EDA. Okay, and as we are doing this KNN algorithm, so it is quite helpful if we know the K value. So for that we have made this K versus you can say this accuracy values. Okay, K versus accuracy. So we are trying to find at which value of K we are getting more accurate. So you can see this is something which we took because we think that that is more accurate. Okay, so let me just rub it down. You can see it is closely matching with each other. Okay, all the other data points are not that much close. This is the first data point also which is closely matching. So we are taking this. This is nothing but K equals to 13. Okay, this is K equals to 13 which will be taking. So we'll see in the coding part. Okay, and under evaluation we saw we are getting good results, accuracy of 90%. Okay, which is a very good result we are getting here. But the thing is, we saw the under feature selection. Okay, pricing is not something which led to customer churn. There were multiple other criteria which led to customer churn. So we'll be talking that in the coding. Okay, so let's see. Okay, let's see. Okay, let's move to this coding part. We'll see this. Okay, so the topic is customer churn prediction for utility industry. So here we are seeing that competitive energy markets, they want their residential customer to be retained. So through various, pricing offers and all, they try to retain their customers. Okay, so PowerCo has given has provided us with this data set. Okay, so this is a freely available data set. Anyone can download. Now this here they are assuming that churn is due to customer price sensitivities, and they are trying to offer them 20% of the discount. So on this we'll be working. Okay, so first of all, we are importing all the dependencies. Okay, the things, all the libraries which we will need. So like NumPy for arithmetic calculation, pandas for data manipulation, PLT for visualization, SNS for advanced visualization, date time to convert our date time into correct format, then standard scaler to standardize our data, train test split to split our data into two categories, training data and testing data using simple random sampling. Then we are also having confusion matrix and accuracy score to evaluate. Okay, this will be used for evaluation. Okay, so I'm totally we are having two data sets. Okay, one is client data, one is this price data. Okay, client data and price data. We are going to combine both of this data, but before that we are doing a feature selection. So whichever feature we think will be needed, we'll be doing that. Okay, so first of all, ID we are taking as our you can say index. Okay, ID we are taking index, and then we are resetting the index, so it will be grouped by ID. Now here we are also checking the price date. Okay, and we are combining the mean year in a single data frame. Okay, so this year and all we are combining into a single data frame. Okay, once that is done, we are trying to extract the contract duration. Okay, and we have created a this function, user defined function. Okay, to find the month difference between various date types. Okay, and we'll be using this to find the difference between these reference time to client date. Okay, so we have also done this, and accordingly we have created this data set. Okay, once we have done all of this, we are dropping the irrelevant columns on which we did modifications. Okay, so two columns are there now on which we did modifications. We are just deleting or dropping the old ones. And then we are on the categorical data, we will be doing label encoding, but this is done manually. Okay, so you can see we are using dictionary to manually do the encoding. Okay, so here you can see we are doing using replace method. We are doing this. So basically everything is being converted into a you can say numerical form. Okay, gas type also we are doing the same thing, and for numerical distribution we are trying to find if they are having a normal distribution or not. If they are not normal, we are trying to convert them using transformation methods. Okay, log transformation methods. Okay, now we have gotten this. After this, we are trying to build the heat map for both of the data sets, price data and customer data. Both data we are trying to build the this correlation plot, and we're trying to find the correlation if multiple things are correlated or not. Here we see in this green one, okay, we are having number of years antique. Okay, number of years antique. So here you can see these two are totally correlated. So we'll be deleting this row, this column. Okay, also we are removing the outliers using IQR values. Okay, outlier removal is done. So everything is clean now. Now we are merging both the data set on ID column. Okay, on ID column we are merging both the data set, and this is the final data set we are having. Okay. It has 44 columns. Okay, and then we try to find the NA values. If there are NA, we are dropping it. Okay, then we are means dividing the X and Y, means output and input values. X is the input, Y is the output. We are doing that here. Okay, then also we are standardizing our data. Okay, the input values, we have standardized it. And then we are splitting the whole data into train test data set. Okay, so it will get total of 4 data set, 4 divisions: X train, X test, Y train, Y test. Okay. Then we are doing modeling part. So here we are doing KNN modeling, K nearest neighbor classifier we are using. Okay, I have imported the classifier and I just plotted this to find the number of K values. So we already know that the number of K values we have taken as 13. So we are doing that. We are taking this 13 and we have trained and fitted the model on this 13 neighbors. Okay. And then we have done a model evaluation. In this, we found on training data, our accuracy is coming out to be 90.3. Okay. On our test data also we see it is coming out to be 90.3. Okay, so same accuracy we can find here. So we say that the model is right fit. Okay, so here by changing this value, we can get different values of accuracy. But as per the chart, we can see that this is the most accurate result we can get. Okay, so this is how we found the, or we had a 90% accuracy in our prediction. So this model can be used to do future prediction of data. Okay. So now that this coding part is done now. Okay, so let us talk about few more use cases. Okay. So this classification, in classification, we can also use this energy analytics to evaluate energy consumptions. Okay. Energy consumptions. So let me give you an example of this. So there was a model in which, first of all, it was a very huge model, as we know that energy models can have a huge amount of data. So first of all, this was compressed using PCA. Okay, using PCA, we compressed this, and this was the data from a building sector. And this, we know that building sector, it is a major source of energy consumption. Also, it is a major source of greenhouse gas emission also. Okay, but the thing is here, a large amount of data is being generated. So first of all, we used here in this project, we had used PCA, okay, to reduce the size of the model, because it is a very high dimension model, first of all. Okay, and then we cleaned and pre-processed the data, which can be used for, okay, which can be used for our usage with the lower models like our data mining models like KNN, okay, naive Bayes, decision tree, ensemble models, okay, regression models also. Now, so this was also modeled according to different climates. Okay, so this was modeled in different regions. So depending on the climate of that region, we also saw that some of the models were performing well for a different climate, and some of the models were performing well for other climates. Okay, so this was also seen. So with climatic change also this differs. The model will differ. So it is not that one of the model will be superior to the other. Okay, so that is another you can say use case, like it is short term load forecasting, short term load forecasting. Okay, this is a application of weighted KNN algorithm. Okay, here we used weighted KNN algorithm, and this weights are nothing but they are the inverse Euclidean distance. Okay, this were used as weights. Okay, and this gave us a better accuracy. And the forecasting errors, they were compared using back propagation of neural network models, and also we used auto-regressive moving average model to find this. Okay, now what is this short-term load forecasting? It is used to forecast power loads in upcoming months or weeks, or even shorter, like daily. For forecast, it can be done with greater accuracy than the long-term load forecasting. Okay, friends, so these were the few use cases. There are many more use cases. If you go through this, many classification models, many regression models will use this, under energy analytics, use this data mining models. So friends, this is the end for today's session. Okay, we saw here classification model using KNN, K nearest neighbor. Okay, let me write the we saw classification using KNN. Okay, friends. So tomorrow again, not tomorrow, Monday we'll have another session of this. On Monday we'll be seeing regression models. Might be simple linear regression or decision tree. Okay, friends. So we'll end our session for today. So thank you everyone for attending.